So I'm Ken Stevens. I am definitely a geek. I love technology. It has changed the world and will continue to do so. I have the best job in the world. I totally do. When I was at Intel, we created the front end of the microprocessor that ran at 1/18th the energy. That's 1/18 over what the current product was doing. It's taken us about 10 years to figure out how to commercialize it, but we're there now. What we call a generation happens about every 2 years. In about 2 years, we've been able to gain about a 30% improvement in performance and about half the energy cost for the function, every 2 years or so. This starts exponentially expounding as you do this over so many years. In terms of how this technology relates to particular applications and in particular, very complicated and more challenging applications such as artificial intelligence. I mean, these sort of algorithms are ones, again, that don't map very well to the traditional way that we've done things in the past. I mean, it served us very well, but our circuits are more like these biological systems than they are, in some sense, like the way we build systems today that are based on a particular clock and frequency. If the circuit gets put into a more positive environment, if it's designed with our relative timing, it will run faster and more efficiently. If it gets put into a less optimal environment, it won't run as efficiently. So our circuits actually map very well to algorithms. And in fact, in many ways, is the way we build systems in hardware is more like the way algorithms, such as artificial intelligence algorithms are built. We have components that we build that plug together that can operate at dynamic frequencies based on the data that you're feeding it, the frequency, and the complexity of the data that you give it. So they can dynamically adapt to both the environment and the data being fed into the system. This is one of the fun parts about what we do and how we do it. Is it sort of unifies the high-level ideas of building these big systems that are changing the world with the circuits and how they actually function. There was a big disconnect between the two. We've sort of made it so it's a much more direct connection between how algorithms work and how the circuits work. And the benefit of that, again, is typically performance, energy consumption, and area. So we're much more efficient because of that more unified mapping of how things are done. Integrated circuits, algorithms, and the systems that we build out of this stuff is totally changing the world.